Hey there, in this video I'm going to show you how to implement the function string length so you can find the length of a null terminated string in a YASM x86-64 assembly program. Although if you're using a different assembly language or different architecture, this video will probably still be useful to you because the concepts are going to be the same. So what am I talking about? What the heck am I even talking about here with this? Okay. So in a previous video, I discussed null terminated strings. I should also point out that a lot of basic knowledge is going to be skipped in this video because I've explained it in other videos. For example, if you don't know how to compile, link, assemble, write a basic assembly program, write a makefile, and so forth, then you should see my other videos first. I've also already published a video about null terminated strings, but I'll just do it again here since that's in the title of the video. So imagine you have a string and it's hello, right? So under the hood, the string is probably a collection of characters on some level. So we'll just say this is H, E, L, L, O, right? When you're printing, you kind of have to know where the string ends, right? Because it's unlikely that your entire memory stick is just done, like you're at the very end of your memory by the time that O hits. So that means you need some way of understanding when the string ends, because if the memory is not over at that point, there could probably be some junk data at the end of it, like a bunch of other random letters. Or you can even imagine these as just, 1 byte, whoops, that's not 1 byte, 1 byte numbers that just go on and on and on forever for the entirety of your RAM stick. And you have to know, how do we actually stop at the O? One thing that you can do is just pre-compute the length of the string. So we do that in assembly a lot before we know how to scan for null terminators. We'll say, all right, well, that string is just 5 long. So I'll tell the system, I want you to print 5 characters starting at that memory location, wherever the H is. And then the system knows, okay, I'll just, print the HELLO and just stop after that. But null terminated strings are a lot more convenient because you don't have to pre-compute the strings. I mean, maybe your user entered a string. Maybe you have a lot of strings or they change quite often. Maybe you have like a multinational program that has tons of translations, or I think multilingual is probably the better word for that. But it can be a pain in the butt to constantly compute the length of strings in advance. So with a null terminated string, you basically just say, well, here's my string that I want to print, and I'm just going to stick actually the number 0 at the end of the string. I'll leave the junk data there just to let you know that there is some stuff happening in memory. Notice how this 0, it is not actually the character that looks like a 0 to a human. That's actually a totally different code than just 0. So you can imagine just an actual 0 here. If we're talking about ASCII or even other schemes, each of these characters that a human would look at has a number underneath it. This H is not really an H, it's just some number between 0 and 255 if we're talking about ASCII. The E is a different number, and so forth. So if we just put the literal number 0 in our data, or if you want to quote this inside of a single quote, you can do, I think, /0 just to let the compiler know that you intend to have the number 0 there instead of something that looks like the number 0, the character. But anyways, the point is we just have to stick a 0 at the end of the string. We call it a null terminator because 0 is also, an alias for null. Whenever you have a null pointer or you assign null to a memory location or a pointer or something, it's 0 basically under the hood. So a 0 will terminate. It'll be like a token to let us know that the string is finished. And so since 0 is also considered null, we'll say it's a null terminator. It's a basic idea for null terminators. Now the question is, how do we actually know when to stop? Well, the first thing that you could do if you're trying to write a program that is highly inefficient, which I've definitely done before, is you could just print one character at a time. You use a for loop. You start at the very beginning of your string, a pointer, whatever the user gave you as like, this is the first character. We'll just print that letter, and then we'll go on to the next letter. And before we print it, actually before we print the first letter even, before we print this letter, we'll say, is this like a regular character or is this a null terminator? Is this a 0? If it's not a 0, we print that character. If it is a 0, we terminate the loop. And then we go through every character one by one, just, checking and printing, checking and printing, checking and printing. Unfortunately, that's kind of inefficient because every time you call print, you're calling on a function, you're asking the system to do some stuff for you. And it would be a lot better if we could just flush the whole string at the same time, but know how long the string was. That would increase our efficiency. So the program that we're going to write together is basically going to use our knowledge of a while loop, which I've explained in other videos already. So see those other videos if you don't know how to do while loops in YASM. We're going to use our knowledge of a while loop to sort of scan the string real fast, just, kind of scan it and figure out how far into the string until we see a null terminator, and use that to determine what is the length of the string. At that point, we can use a system call in YASM, in assembly, to just say, I want you to print this sequence of characters, and here's the length. And then let the system worry about efficiency. So with that said, let's look at some code. Okay, it's just going to be a simple while loop. What we're going to need to do is break this up into two parts. The first part is going to be a function called string length, which you've probably already seen in C if you program in C or C++. The second function is going to be called print null-terminated string, which will just ask string length what the length of the string is first, and then actually print it with the system call. So let me, I guess let me start off with my data section here. So I'm going to do data section. I'm going to copy paste that from my solution. Again, this is not an assembly basics video, so if you don't understand what I'm doing, you should watch my other videos first. I'm assuming you know how to make a data section by now. We'll put some C strings. I'm just going to make one null terminated string. Actually, I guess I'm making two, but the focus of this program is just the first one. I'm calling it null terminated string. And in assembly, it's pretty easy. You just make it a character array, just like a sequence of bytes with this DB, meaning data bytes. And I can just put a quoted string like this, no problem. As many characters as I want. I can start injecting specific ASCII values if I wanted to, or byte values if I wanted to, just by putting a comma and then a number. So I could do something like this. I could do like, 47, 49, 50, whatever, if I knew the ASCII codes for the characters. Fortunately, I don't need to. I can just type them normally into the double quoted area. But then I need to be able to put a null terminator at the end of my string because it's not going to happen automatically. So then I am going to do comma 0. And you'll end up with something like this. Like I guess if we look at the previous example real fast, I'll call this a hello string, just so that you see some similarity from what we just looked at. If we pin this up to the side, maybe. Doing this, a notepad thing would just be typing the word hello and then putting comma 0. So it is now a null terminated string, and it looks just like this inside of system memory. Well, not just like that. There would be numbers where the letters are, but that's basically what we have created. And then, of course, there's junk data afterwards, but we don't really care about that. We're just going to ignore it with the null terminator. So I'm going to erase that since we're not just going to print the word hello. We have a null terminated string here, and then after we print the null terminated string, I'm just going to print out what was the length of the string. So this is a prefix string where it's just, it's a prettier program. The program is going to say the null terminated string's length was something. And then we're going to use the null terminated string printer to print that also. Convenient, right? And then I'm going to actually print the number. Then we have this down here, CRLF, which is just printing a new line in the terminal. That's character code 13 and then 10 and then a null terminator so that we can use the null terminated string printer again. And then we're going to use system call code 1 to print the standard output right here. If you don't understand that, then see my other videos. But let's move on to the text section where all our instructions will go. Okay, so now the instructions begin in our text section right here, section.text. And I'm using an external symbol. This video is not about this library here, but basically I have a library that'll help me print integers. You don't need to worry about that. You could imagine, well, I guess in your example, when you're practicing, if you don't have this library, you could just not print the length of the string and just use it only, and it all should still work. Or you could hard code the thing that you're printing if you really wanted to. Okay, so I'm just going to continue on here. Now let's do our entry point. So again, this is not a video about hybrid programs. Just assume that there is another module in my program. It's a C++ module. It's got the main function, for the entry point for a hybrid program, and it'll just call on my looper function. So that's why I'm marking a looper as global, so my other module can call it. And well, it is a function that needs to return, so I'm going to put ret at the end of it. And you can see here I left myself a note saying I'm going to use R12 to remember the length of the string so that I can print it back to the user. So that means I have to preserve R12 for the caller, because the ABI, or the application binary interface, says that R12 is a callee-saved register. And if you don't respect the ABI is not going to respect you. Your program's going to end up crashing eventually, especially if it gets complicated. So I'm just going to do a push pop pair to preserve R12. Whoops, Prologue, and call that epilogue. Okay, so we got a push pop pair, we got a return statement. This program should probably do nothing so far. So let's run it and see, just make sure that it at least compiles. So I'm going to say clear and make run. Running the program. Hello from the driver. You don't know that the driver has that. This is not a driver video. And then the driver regains control because nothing happened inside of the assembly module. We just basically, looper got called, and then we preserved R12 and then restored it, and then we did nothing. Okay, so now let's make a call to print null-terminated string. We have to make another function for this, but right now, this is just the call. So the name of the function that we're going to write is called print null-terminated string. Inside of it, it will call on the string length function to figure out how long the string is. Then it will use a simple system call to print the whole string, giving the length to the system call. It also takes two arguments. The first argument is a pointer to the null-terminated string, so that's just that symbol we defined up above. Remember, when you define variables up in the data section, then these symbols tend to be pointers. So that symbol is a pointer to the H, basically, or just the memory location of where that H is sitting in RAM. Then the second argument that it wants is where we're going to print it. So we're just going to print it to standard output, which is just file descriptor number 1. So again, if you don't understand arguments or file descriptors or function calls, see my other videos because I've explained those already. Anyway, so we're going to call print null-terminated string, then we're going to call on CRLF, which will just print a new line. So now maybe we should implement, well, let's copy paste CRLF so that I can implement the other function a little bit more slowly. What does CRLF do? It literally just asks the print null-terminated string function to just print a CRLF for us. So it's very, very simple. Here's the signature. Nothing much to it. Okay, now a little bit more complicated is the print null-terminated string function. So in our looper, we're going to print the null-terminated string. We have to have a function that actually does that. So that's going to be this one right here. Here's the signature that I've chosen for my print null-terminated string function. Basically, I want to receive a character pointer to the first character in the string that we're going to print, and then a file handle designating where we're going to print it. The reason I want to receive the file handle is so I could print to standard output or standard error, or I could print to a file, like whatever I want to do. You don't have to have that in there, but it's nice. Anyway, so we have this function set up. Notice how my notes that I left for myself is that I'm going to use R12 to remember the incoming C string pointer argument, and I'm going to use R13 to remember the file handle. Remember, it's probably not a good idea to just let the incoming arguments stay in their original registers, because those registers tend to get overwritten as you do system calls or calls to any other function. So I'm just going to grab them real fast into R12 and R13. And then R14 is the string's length, which I'm going to compute with a call to the function called string length. So just 3 things to remember, and that's it. So that means I'm going to have to preserve those 3 registers. Spec the ABI, or the ABI will crash you. Okay, so we're going to do a prologue to preserve those registers. And then at the very end, we're going to do an epilogue where we restore those registers. Oh, I think I already overwrote my return statement from the previous function. I think I did that in the last video, and I was a little confused as to what was wrong. So make sure you don't accidentally overwrite or push down your return instructions. Let me just double check here. Looper's got return. Print null terminated string has got a return. CRLF has a return. What the heck did I do? Oh, I think I copy pasted in a bizarre place. That's probably what happened, because the epilogue for print null terminated string is like down in CRLF already. That's not good. Okay, that would have been a crashing program. Although sometimes if you omit the return statements, execution will just fall through down to the next label and maybe your program will survive accidentally. But for now, it's just CRLF is supposed to be very simple. It doesn't preserve any registers. So we've got a prologue and an epilogue here. Notice how the push and pops are in reverse order. If you want to know more about that, see my other videos. But now that we are preserving the appropriate registers, we can actually grab our incoming arguments. So first thing I'm going to do is I'm going to say R12 is going to be the first argument that I received, and then R13 is going to be the second argument that I received. Okay, no problem. Then let's rely on the string length function to compute the actual length of the string. I didn't feel like having print null terminated string compute the length of the string. It's a good idea, especially in assembly or any language. When you have multiple distinct jobs happening within the same function, you probably want to break that function up into multiple functions just to reduce, strain on your brain, right? Cognitive load. So I'm going to use this function strlen, string length, to compute the length of the string. It's only going to take one argument, and it's going to take the pointer to the null terminated string, which is now in R12. It's going to take that as its first argument, so that's why I'm loading that up into RDI. When string length returns, it's going to give me the length of the string in the RAX register, which is the usual return register for integer or pointer return types. So I'm just going to save that in R14, and that's the usage of all those registers, R12, 13, and 14. We still have to implement string length, don't worry. Although, if you were linking a hybrid program, you could probably just call strlen in the C libraries and be fine. But this is an assembly video. We want to do everything in assembly if we can, or at least more of it. So then finally, when we know what the string's length is, we can just use a regular system call to actually print the string. We're going to say load up call code 1 to say, Mr. System, I want you to print a string. And then R13 is going to be the file handle. So we're going to basically say, wherever the caller of print null terminated string said to print, which is probably going to be standard output, we'll just tell the system we want to print to the same place. And then R12 is a pointer to the C string. So we just give that to the system call as well. And then the system call wants to know how long the string is. That's R14 now that we have used strlen to determine the length of the string. So not really that complicated of a function. We just kind of like grab some arguments, preserve those registers, and we ask another function to compute the length of the string, and then we actually just print it once we have the length. This is still not getting to the point where we're going to use our while loop knowledge to compute the length. So I think that's probably all I need right now. And I think we're ready to use or to start the string length function. Okay. So now let's make another function called string length. Hopefully I'll paste in the right spot this time. You're cringing at home. That just tells me that you care. So the string length function, at least the version that I'm making right now, just is going to take one argument. It's going to be a character pointer to the string that you want to compute. It will expect that the string has a null terminator at the end. If you accidentally didn't put a null terminator at the end of the string, then this function definitely won't work. It'll probably give you some huge number because it'll go through RAM until it accidentally finds a 0. And then it's going to return to you as its return value an assigned 64-bit integer. Actually, this should be unsigned, but I'm just putting long for now to indicate the length of the string. Okay. Inside the notes, we're going to use R12 and R13. So that means I should probably preserve those registers first before I do anything else. So in the prologue, we're going to push R12 and R13 so that we don't break this program for others. And then we're going to do an epilogue. Whoops. Then we're going to do an epilogue to restore the registers. And this is a function, so it's got to return to the caller. If I didn't put a return statement here, then execution is going to just go all the way down to CRLF. And this will be an infinite loop because CRLF will end up calling null terminated string, which will then call string length, which will then fall through to CRLF. So the whole program won't even work if we don't have return. And you know, you don't want to omit return statements anyways, because that's always a bad idea. So now string length will just not do anything right now. Maybe we could return a fake value for a second before we start implementing the loop. Let's move the number 5 into RAX, so that string length will always trick the caller into thinking that the length of the string is 5. Let's see if that actually works. We should get a portion of the null-terminated string, unless I screwed something up. Hello from the main driver. Notice how it just says hello here? That's kind of confusing. Let's hard code the 5 to like a 9. We should see more of that null-terminated string. Hello, right? That's how I sound when I wake up sometimes. Hello. Okay, so let's finish the strlen function. So again, you should know how while loops work if you don't see my other videos, but we're going to use a while loop to count the length of the string. So we're going to start with a little portion up here that says, let's initialize the length that we think the string is and a running pointer. So RDI is already supposed to come in as a pointer to the string that we're measuring. So I'm going to save the pointer into R12 so that we can have a pointer that points to a character. We're going to use this as a running pointer, so it's going to like sweep through the whole entire string until it hits a null terminator. And then R13 is going to keep track of how big we think the string is. So when we first start, we're just looking at the first letter, and then we think the string has 0 length. So that's the initialization part, which will not be repeated as we continue looping. Now we're going to implement the top of the loop. I don't know, should I write this out as C code for you? I don't know if I should. Maybe let me do it. I didn't prepare this, so if it's slow, sorry. Let's do while here. Maybe we'll start off by saying, maybe this is like a long strlen, something like that, and then we'll do, if my code is wrong or doesn't compile, I'm so sorry. I did not prepare this. We'll say character pointer s, and then we'll say, maybe we can actually just leave s alone because it's coming in as an argument. And in C++, you can just continue to use that symbol. It's not going to get destroyed. So imagine we've saved it already into R12, and then we just keep using it. So we'll say while let's say a dereferencing of s is not equal to 0, meaning if we look at the value that the pointer is currently pointing to, if we assume it's just pointing to 1 byte, we'll keep going as long as that value is not a 0. So that means if the user called this function and gave us a pointer that was already looking at a 0, then right away we would just return, that the length was 0. So that means I should probably keep track of the length here. Size type, actually long, just to match the return signature. Long, we'll put size equals 0. And then at the very end, we'll just return the size. And so again, if the user gave us a pointer that pointed to a 0 already, nothing would happen inside the while loop. We'd break through it right away, and we would just return the number 0. That makes sense. So then as long as it is not pointing at a 0, we'll just increase what we think the size is, and then we will increase the pointer. We can use s++ in C++. That's just pointer arithmetic. That's just going to tell the pointer to advance, one memory location further, or whatever the data type is. But in this case, the data type is a character, so it really is going to be 1 memory location, 1 byte. So we're going to sweep through the string until we see a 0, and then we stop. And every time we see a character that's not a 0, we increase our measured length of the string by 1, and then advance the pointer. So I haven't tested this. I don't know if there's an error in it, but I hope you get the basic idea of what we're going to do. So that means up here, this is the initialization part that we were just talking about. So we just set the running pointer to look at the incoming argument, and then the known length to 0. Okay, so then after we do that, we are going to make the top of the while loop. So at the top of the while loop, where we evaluate, like right here, this is the top of the while loop. It has to have its own label, just like we explained in the other videos. And it is basically where we decide if we're going to keep looping or not. Are we going to jump into the body of the loop, or are we going to do a long jump after the body to say that we're done? So the top of the loop is a label. We compare the value that R12 is currently pointing at. We say that we only want to look at 1 byte. We dereference R12 because remember R12 is supposed to be a pointer. If you put the brackets around it, it's going to go to the memory location and then check what the value is that the pointer is pointing to. That's what dereferencing is, right? So we're just going to compare the byte that we're looking at with a 0, and we'll say if it is equal to a 0, then we're going to jump to the done. This is actually kind of a poor design pattern on my part. Usually we should jump, if it's not equal, into the body, meaning we'll always take a short jump into the body, and then execution will fall through on the next line to a long jump, which has the ability to jump further out of the body. I've said in other videos that the conditional branch instructions, they can only jump about 128 bytes. So if your loop body is too big, then they won't work, but it'll work for this example. I don't know, maybe if I have the gumption, I will fix up the loop for you if you want me to, after I copy paste my existing solution. So for now, we're going to say, all right, I'm not going to do it. I'm not going to do that. Maybe in another video, if somebody requests it, I might post another video in like 5 years. Anyway, so we're going to jump if it is a null terminator to the done label. Otherwise, we will fall through to the loop's body, where we're just literally going to increase the pointer and also increase our idea of how big the string is. So remember, R12 is the pointer. Integer arithmetic doesn't, or sorry, pointer arithmetic doesn't really work here, but it accidentally works here because we're looking at a byte array. So if we just increase by 1 memory location, it will literally just increase by 1 memory location and we'll be fine. Just keep in mind that if you were sweeping through an array of, quad words or some larger data type, then just a simple inc wouldn't actually work. You'd have to increase by the appropriate number of bytes. But hey, the number of bytes in one item is just 1 byte, so it's easy. So we're making the pointer go forward by 1 on line 134, and then in line 135, we're increasing our idea of how big the string is. And then we will unconditionally jump to the top of our loop. And so if you just kind of look at this, what did I do? I pasted that twice? Oh God, okay, sorry. Guess I lost track of what I was doing. So then we will unconditionally jump to the top of the loop. So basically you can imagine this loop is just gonna continue forever, just moving the pointer and increasing the counter and moving the pointer, increasing the counter. Finally, when it sees a 0, a null terminator, then it actually breaks to the done label. And the done label is just, it doesn't really do much. It's just a label to get us out of the loop. So the top of the loop says, if we are done, then just jump to the done area. Notice how that skips over the top jump. And then of course under that is going to be the epilogue, and then we can take the return value and set that up now, because at this point R13 should contain the actual length of the string. So if we move that into RAX, respecting the ABI for return values, then the caller should be able to get the string length just at that point by itself. So let's see, that might actually be the whole entire program already. Let me double check here. All right, let's run it and see if it actually works. So I'm going to clear it again and then do a make run. What's up with those asterisks? Did I put that in there? Oh, I wonder. Okay. So the driver comes in, it calls on our function, and the whole null terminated string gets printed out. It says, hello, this is an example of our null terminated string. Notice how it printed the full length of the string, not any less, and it also didn't print more than the length of the string, i.e. junk data, because it knew exactly how long the string was. And this is way better than printing 1 character at a time in terms of efficiency. We just pre-compute the length and then print exactly that length, and then we're done. I think there is one more thing I wanted to do here. Let me see. Up at the top. Yeah, okay, let me go back up to the top of the program here. So in the looper function, we called on print null terminated string and we didn't do anything else. So what I would like to do is just make an explicit call to string length inside of the looper function, just to get the length of the null terminated string so we can just print it to the caller or print it to the user. And then I'm going to use my special library function here. Actually, just for your information, notice how I'm calling string length, just like the print null terminated string function did. And I'm just giving it as an argument a pointer to that null terminated string. So then it should return to me in R12 what was the length of that string. So now I can just print R12. Well, not yet. I'm going to print a prefix. If you look at the prefix here, it's just the null terminated strings length was, and then I'll print a number after that. If you do it this way, you know, your program is more pretty. It's more nice to the user and so forth. So I'm going to do this. So basically we're printing a nice prefix, a hard-coded string to the user to let them know that I'm about to show them the length of the string. And then I use my external function that just prints a number to the user. Again, this video is not about this library. You can use some other library if you want to print something. Or you can omit that part if you don't have one set up yet. So I'm going to tell, I'm going to do first argument is R12, which was the length of the null terminated string that I got on line 60. And I'm going to call this function and say, I would like you to print R12, which is the length of the string. So after that, we'll print a new line to make things a little bit tidier. And then I think this program is actually finished. Run it again. Now it says, here's the null terminated string. And then on the next line, it just says, the null terminated string's length was, that was the prefix. And then when I called my library to just print the number, it says 54. So I don't know, was it 54? Let's just double check to make sure that it actually was 54. 54 should not include the null terminator. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 5, 6, 7, 8, 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 50. 51, 52, 53, 54. Was it 54? I can't even remember anymore. That rhymed. Yeah, 54. So we have basically proved that this works. We have leveraged our knowledge of while loops to implement a string length function, which will let us have a printing function that is very smart. So we don't have to hard code string lengths up at the top anymore. As long as we're working with null terminated strings, everything will just work out now with less variables or less defines. Okay, let's see. I think that's pretty much everything that I wanted to talk to you about. I don't know. Could I do this easily? Loop top. Loop top. Okay, yeah, I think I could probably do this reasonably. So at this point, if you are satisfied that you understand how to implement this and you're happy, just cut the video. The rest of this video is going to be me sort of like improvising, trying to figure out if I can rearrange the logic in a fast enough time for a video. Just to show you that, you know, you should probably write your loops a little bit better than I did. So here we go. But this is just redundant stuff. So we have our loop here, and we have our initialization portion, which is fine. And the loop top, it should compare R12 to 0, and it should break the loop if it is a 0. So that means I'm going to comment out this, and I'm going to do jump not equal to 0 to the body. And I just need to make a label for the body here. So I'm going to say strlen loop body. So there's a label, which is the body. Maybe I'll do a comment here just to remind us that this is actually the body. I guess I'll do another comment right here. So that's the loop's body. So I'm going to say if R12 is not a null terminator, jump into the loop's body. Otherwise, we fall through to the next instruction, and that will just be an unconditional jump to the done area. Okay, and then when we're inside the loop's body, we'll jump back up to the top. I don't know why I thought this was going to be hard. Let me run this to make sure I didn't break the program. Yeah, it still works. Okay, I guess I overestimated the difficulty there. The point being, the body is a lot closer to the top of the loop, so that should be the thing that does a conditional branch. You should conditionally branch to the body because it's a shorter jump and therefore much less likely to be out of bounds of that 128 conditional jump byte restriction. And then when we fall through to the next line, because we did not do that jump, then we'll do an unconditional jump to the done area. And, you know, our loop is small, so it didn't really matter the first time we did this, but Again, imagine your loop is huge. You definitely want an unconditional jump that goes to the done area at that point. And that's also why we're doing an unconditional jump to the top here when we get to the end of the body. So when you're jumping large, spans, you want to use unconditional jumps. All right, so I guess that's it. I'm going to erase maybe this comment. Well, I'll leave that in there just for posterity. And now I will officially say that I hope you had a good time watching this video. I hope you learned a little bit of stuff, and I hope you had a little bit of fun. I will see you in the next video. I'm going to go play some video games. Maybe I'm going to eat some soup first. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.